Every day, all around the world, hundreds of little earthquakes shake the ground beneath our feet. Most of them are so tiny that people don't even notice them. But sometimes, an earthquake can be big and strong, shaking buildings and roads like in a thrilling movie scene. So, what exactly makes the earth quake? Imagine our planet Earth like a giant turtle shell. The shell is not all one piece but made up of many different sections. These sections are huge slabs of rock called tectonic plates. And they're constantly moving around, although very slowly. It's almost like they're dancing on the surface of the earth. Now, picture an enormous dinner table where each place setting represents one of these plates. But unlike a calm dinner party, these plates have minds of their own. They drift, shift, collide, or sometimes slide past each other. When they bump or rub together, it's like a dinner plate clinking against the silverware, sparking a powerful tremble. But the shaking usually starts way beneath the surface of the earth. When the plates move too much or too fast, tension builds up in the rocks below. It's like pulling on a rubber band until it snaps. The energy released from those snapping rocks sends shockwaves that tremble through the ground. Most earthquakes are born at the edges of these tectonic plates. When they slip or crack, they create a roaring rumble that can cause the ground above to shake. These edges are called fault lines, kind of like giant zipper lines across the earth. One famous fault line is the San Andreas Fault in California. It's a bit like the Earth's own seam, where the Pacific Plate and the North American Plate rub shoulders. Sometimes, the Earth gets uneasy, and earthquakes are its way of letting off some steam. There are places where earthquakes happen more often and places where they're quite rare. Areas near the edges of plates or fault lines tend to feel the most trembling. If an earthquake is strong enough, it might topple buildings, crack open roads, or even send big waves crashing onto coastlines. So, an earthquake is not only a reminder of Earth's movements but also a demonstration of its incredible power. And while they can be scary, scientists work hard to understand them so they can better prepare and keep people safe. Next time you feel a little rumble underfoot, remember that somewhere deep down, the Earth's plates are dancing their slow, majestic waltz, showing us all how alive our planet truly is.
The Civil Rights Movement was an important time in U.S. history when people worked together to end unfair treatment, mainly of African Americans, and to make sure that everyone had equal rights under the law. A long time ago, there were laws called segregation laws in many parts of the United States. These laws said that black people and white people had to be separated in almost everything: schools, buses, restaurants, and even water fountains. They were not allowed to use the same things or go to the same places. This was very unfair. Many brave people decided to stand up against these laws and try to change them. This started what we call the Civil Rights Movement. The movement was especially strong from the 1950s to the 1960s. People organized marches, protests, and boycotts to show that they wanted change. One of the most famous leaders was Dr. Martin Luther King Jr., who was known for his speech, "I Have a Dream." His dream was that people of all races could live together peacefully and have the same rights. There were other leaders, too, like Rosa Parks, who refused to give up her seat on a bus to a white person, which started a big protest called the Montgomery bus boycott. Many laws were changed because of the movement. The Civil Rights Act of 1964 was a major law that helped stop segregation and unfair treatment. Another important law was the Voting Rights Act of 1965, which made sure that everyone, no matter their race, could vote in elections. The civil rights movement was not easy. People were often arrested or hurt for standing up for what they believed was right. But their hard work and bravery paid off, and today their efforts are remembered as a major step toward equality for everyone. Although the movement happened many years ago, its impact is still felt today, as it helped the United States move toward a more equal and fair society for all people.
Once, the Buddha gathered his disciples on a day of full moon for a sermon at Vulture Peak. Rather than offering words, the Buddha simply held up a single golden lotus flower, gleaming gently in the sunlight, without uttering a single syllable. The assembly of disciples sat in quiet contemplation, each pondering the meaning behind this silent gesture. After a moment, Mahakassapa, one of the revered disciples, responded by smiling warmly. His serene and knowing smile was enough to signal his deep comprehension of the Buddha's unspoken teaching. The Buddha, recognizing the profound insight of Mahakassapa, declared in front of the gathered Sangha, "I have the treasure of the true Dharma, the wonderful mind of Nirvana, the true form of no form. It does not rely on letters, and is transmitted beyond doctrines. I now entrust it to Mahakassapa." This episode marked the transmission of the mind-to-mind enlightenment from the Buddha to Mahakassapa, a significant moment that laid the foundation for the Chan Zen tradition, wherein true understanding arises from direct experience beyond words and scriptures. Thus, the power of silent understanding showcases the ultimate realization that transcends conventional discourse and connects directly to the essence of reality. The Buddhist principle embodied in this story is that true understanding requires no words. As a great master once said, the true form of no form escapes the practice of speech.
Every ending invites a new beginning. Success is not final, failure is not fatal. It is the courage to continue that counts. Winston Churchill. Do not be embarrassed by your failures, learn from them and start again. Richard Branson. Failure is simply the opportunity to begin again, this time more intelligently. Henry Ford. When you lose, don't lose the lesson. Dalai Lama. Our greatest glory is not in never falling, but in rising every time we fall. Confucius. Success consists of going from failure to failure without loss of enthusiasm. Winston Churchill. Embrace the chance to rebuild with wisdom earned from the past.
Have you ever noticed how boats seem to glide over the water, while rocks plummet straight to the bottom? It's a fascinating question that might make you wonder about the mysteries of nature. Today, we're diving into the world of physics to uncover why some objects float and others don't. This is a classic Type C article, where we explore a natural phenomenon. Let's start with a simple curiosity-sparking question. Why do boats float but rocks sink? You might think that it's because boats are made of special, magical material that makes them defy gravity. But the truth is much more scientific, yet equally surprising. At the heart of this mystery is something called buoyancy. Buoyancy is the force that keeps objects afloat in the water, or in any fluid. Imagine it like hands gently pushing the boat up from below. It's this buoyant force that allows boats to stay on top of the water. But how does buoyancy work? Buoyancy depends on two main things: the density of the object and the density of the fluid it's in. Density is how much stuff is packed into a given space. Things that are less dense than water will float, while things that are more dense will sink. Let's try a fun experiment in our imagination with a big rock. Rocks are solid and have a lot of stuff packed tightly into them, which makes them dense. When you drop a rock into the water, its density is greater than that of water, so it sinks. Now let's look at boats. Boats are made up of many different parts, but they often have big, hollow areas called hulls. These hollow spaces mean that, overall, boats are much less dense than rocks and even less dense than water. The air inside the hull reduces the boat's total density, allowing it to balance on the surface of the water, just like a balloon full of air would. To add to the buoyancy, boats are designed in a special shape that helps them displace water.